Now, I'm going to leave a resource of how the configuration file in Nginx works. There's great documentation online, and as with all configuration, you don't have to memorize these things. These are just things that you're going to look up when you actually implement a load balancer. So I'm going to just start off with some basic setup. First, I'm going to say that the worker process is going to be 1, or I don't need the semicolon. Now, what does that mean? Well, the number of worker processes is defined by this file and can be whatever we want. We can add 2, 3, 4. These are worker processes. And it usually matches the number of CPUs you want to use. So for example, if you had 4 CPUs on your machine, then you might use 4. For now, I'm just going to leave it at 1. Next, we define the events. And these events are going to have something called worker connections. And I'm going to say it's going to have 1024. And you see 1024 or 516 as the default here quite a lot. Again, this sets the maximum number of simultaneous connections that can be opened by a worker process. So we have 1 worker process, and these are the max simultaneous connections we can have. And then finally, we get to the fun part. We define the HTTP. And this HTTP we'll have to tell it that we want the load balancer, Nginx, to pass on to the servers that we have. So in our case, I'll say server web1 is going to be on port 3000. And these are going to match the names that we have over here and the ports associated with them. So I'm going to say server 1 is going to be web1 3000. The next one will be web2 3001. And then finally, server web 3 will be on port 3002. And now that I think about it, most likely these web servers are going to be opening to the same port because we're just replicating them. So most of the time, these are going to have port, let's say 3000 consistently open. So I'm going to just change that back to 3000 and 3000 and do the same in my Docker file. Going back here, I'm going to now, we have to make sure that we can use and reference these somehow. And the default way we do this is we use upstream. And upstream, we can just call this whatever we want. Let's just call it my app1. And we're going to wrap these up here. And I'll show you what this does in the next line. So we've said that the upstream is going to be my app1 that will contain these 3 servers, and not server. We can now say that the server is going to listen to port 80. And I got to make sure I don't forget the semicolons here. And then I'm going to say that the location of the default route is going to lead us to what we call a proxy pass. So remember how I said it's going to be a reverse proxy? Proxy pass simply says, I want you to access the my app1 we just created. So this upstream, my app1, can now be referenced in the proxy pass over here. So we're simply saying, hey, if we hit the main route like this, just pass all those down to server 1, server 2, server 3. Again, this is all pretty well documented in their configuration. It's unique to Nginx, so it might look confusing now, but it's just the default way to set up a load balancer. And now we have everything pretty much set up. But we can also do some cool things with Nginx. For example, if I was serving static files, I can say location, and by using this little syntax, I can say serve any CSS, JavaScript, GIF. What else we have? We have JPEG. We have PNG files. And anything that includes those, I want you to just cache. So if we ever have any of these files with these extensions, well, in that case, just cache them using expires parameter. And we can say anything we want, like 168 hours. And that's it. Let's make sure I remember all the semicolons here. And this is a typical Nginx configuration file. Again, all we're really doing is just saying, hey, reference my app 1, and this is going to include these servers. And we're going to do a proxy pass through these, and we're just going to listen to port 80. All right, so let's save this. I'm going to go to Docker Compose. We now have an Nginx folder that will run the Docker file, and it's going to move our configuration file that we've just created onto our container. So let's give this a run and see how this works. First, let's run npm or docker compose up -- build and see if everything is working. And we get a bit of an error here because I did make a tiny mistake. And that is over here, it should be worker processes. Even though it's 1, because it's expecting sometimes more than 1, it should be worker processes. So let's save and try that again. Going to close and redo all of that. Hey, look at that. Server running at these ports. Remember, this local host is within the container though, so we can't really access it. But we have our web servers running. So if I go to localhost port 80 now, let's give that a go. Localhost, and instead of port 3000, we'll do port 80. All right, we got some sort of a response. If I open up the console, there's no errors, but check this out. If I go back now, I see favicon requested, and also I have been hit. Web 1 has been hit. So it just responded. Now, if we go back and refresh again, go back, we see that, okay, now we have Web 2 that was hit, also Web 3 that was hit, and favicon is requested from Web 1, and the load balancer is just in order hitting each one of these servers. And if we go back to the configuration file, you can actually define up here how you want to distribute the weight. For example, you want Web 1 to have get twice as many requests as Web 2 and 3. You can do that. You can have different orders, but for now, it's just hitting them one by one in order. 1, 2, 3, then 1, 2, 3, 1, 2, 3. Very, very cool. And that wasn't very hard to implement, right? Now, here's the exciting part. Let's have some fun with this. We now have a load balancer that's passing down requests. What if we just hit it with a ton of requests, with hundreds and hundreds of requests? Well, we can do a bit of a load balancing testing, a load testing. And luckily for us, there's a ton of resources that we can use here. We're going to use the load test npm package, but there's a lot of fun sounding ones like artillery. There's siege that you can use, and also the very popular WRK2. And all of them pretty much do the same thing. They simulate requests, and we can tell them how many requests we want to hit at an endpoint. So let's use load test. All we need to do is just globally install load test, which I already have. And you might have to run the sudo command. And after that, you have the load test command available to you. So let me demonstrate something. I'm going to say load test and run this command. Let me make this a little bit bigger. Now, load test -t simply says T for time limit. That is, I want you to do this load test for 5 seconds. And then -c means how many number of clients do we want to create? So we're creating 100 clients, and 100 of them is going to arrive concurrently onto the server. And then finally, we have the --rps, and this stands for rate of requests per second. So we're going to send 100 requests per second to localhost 80. Once I hit enter, check out what happens on this right side. Ready? Let's give it a go. How cool is that? And you can see here it's going really fast, but it's alternating from web 1, 2, 3, 1, 2, 3, 1, 2, 3. And we also get a nice little summary of what we've done. If I make this a little bit smaller so we can see better, we see that we've completed 499 requests, 100 requests per second, as we've said, 100 concurrency level, again, as the parameters that we gave it. We hit localhost 80. We ran the test for 5 seconds. And the mean latency, how long it took to respond, was 5.1 milliseconds, fairly fast. And it shows you some more info of how many of the requests served within a certain time. So that looked pretty good. Now here's a little fun experiment. What if I close this, and instead of the Docker container that has the load balancer, what if we just run npm start? I've set it up so that the server, which is just one single server, is listening to localhost 3000 now. Remember, our server.js file is just a simple server. So now that I'm running it on localhost 3000, we can test what happens when there's no load balancer and just one server. All we need to do is run the same test, but this time, instead of port 80, we do port 3000. Let's give it a go. And you see that the server is responding with console logging it. It's been hit for 5 seconds, and then we have a response. That's interesting. So let's have a look at this. We see here that we have, again, 500 completed requests, no errors, just like before, but the mean latency was 2.3 milliseconds versus 5.1 milliseconds when we had the load balancer. Interesting. So not having a load balancer was actually faster here because all the metrics are the same except for the fact that the mean latency was a lot faster. And that might make sense. One, because, well, we haven't hit it too much with too much traffic. And also the fact that we're running this load balancer in one container that has a load balancer and 3 web servers. In real life, we wouldn't actually do this. Each one of those services will be on different machines, different containers. So that causes a bit of delay as well. But let's increase a few more things. Let's say that now I want to have 500 requests per second. I'm going to press enter. All right, that's good. We're not getting any errors. It's able to complete the requests. That's great. What if I do even more? What if I do 1,000 concurrent requests? All right, so it did some work. It has 2,989 completed requests. Let's run the Docker Compose, the load balancer, and see how that's going to work. Again, I'm going to run the same thing, but this time on port 80. Let's run that. All right, it's doing some work. And oh boy, those numbers don't look very good, do they? We have mean latency of 143 milliseconds versus 2.9 seconds. And the completed requests are, well, actually less than when we had the one server. And again, because we're running this on a container, it is slower than if you actually implemented load balancing properly. But using this tool, I want you to play around and experiment with different things. See if you can make this load balancer faster than the localhost method. Mind you, if you're running a container, you may not get that, but see how far you have to go to make this fail. I hope you have a good idea of running a load balancer, how it might work, how you can implement it, and also how to do something like load testing to see how good your server is at getting requests and when you might need to actually upgrade, maybe have more servers, maybe have a load balancer in front of your server. All right, Go have fun out there and load test and have fun with the load test tool. I'll see you in the next one. Bye-bye.